Hello. Yes, I will welcome you back to PSSB, Physical Sciences Silver Bullet. It's me, Richard, once again. Now, we are looking at this question today. It comes from vertical projection, and the statement reads that a ball A is projected vertically upwards at a velocity of 20 meters per second from ground. 1 second after ball A is projected, a second ball B is vertically thrown downwards at a velocity of 10 meters per second from the top at a height of 38 meters. So the question says, determine the height above the ground when ball A passes ball B. Okay, this is the scenario you're having. Okay. This ball is projected upwards, and when it has moved 1 second, then ball B is projected downwards. Okay. And we need the time, the height above which the two balls pass each other. Okay, when you look at this scenario, what do you do? Okay, here we have to realize something, that ball A is moving for 1 second before ball B starts moving. And what are we doing here? We want to compare the two balls to bring them into motion, both of them. But one moved before the other. What do we do? So what we are going to do, we are going to find out the height or the displacement covered by ball A before ball B started moving. And in that displacement also, we need to calculate the new velocity after 1 second. So after finding those two variables, what do we do with them? Now we can equate ball A and ball B because they'll be now both moving. So we are going to use this 1 second. So it is this 1 second, this 1 second which is causing the difference. So let us sort it out. What are you going to say? So we are going to say displacement covered by ball A in 1 second. Okay, because we need it. Okay, how do you go about that? This is what we know. For ball A, we know initial velocity, and it is 20 meters per second. By maintaining it positive, it means that I've chosen upward positive. So my G is going to be negative 9.8 meters per second squared. Okay, what else do I know? I know the time is 1 second. What else do I know? I'm looking for my unknown, which is delta x. So when you look at this data, what equation does it give you? Okay, it gives you the third equation, which says displacement is equal to vi delta t plus a half a delta t squared. So what does that mean? Vi is 20 times 1 plus a half times negative 9.8 times 1 squared. What do we get out of that? What we get out of that is going to be the displacement. There it is, 15.10. So in 1 second, ball A covered displacement of 15.1 meters. Okay, then what comes again? We need a new velocity. So velocity of ball A after 1 second. Okay, to do that, what do we know? We need the data. Vi is 20 meters per second. G is negative 9.8 meters per second squared. I'm looking for VF. What else do I know? I know time, which is 1 second. So when I look at this data, which equation is this one? Is the first equation, which is VF is equal to VI plus A delta. Okay, what do we have here? We are looking for VF. Vi is 20 plus negative 9.8 times 1 second. What you get here will be the new velocity. So there we are. With our displacement and with our new velocity. So what does this mean? This means this. It means that ball A moved a displacement of 15.10, something like, suppose this is what we are taking, and its new velocity at this point is going to be 10.2 meters per second. So with this information, this is what we are having. Now we're having the two bodies, both of them. Our assumption is that now these features, these calculated values are going to be the initial compared to the B. So now the two balls can be equated. Or what are we going to say? That ball A moving at 10.2 meters per second upwards is on head-on collision with ball B, which is moving at 10 meters per second. And the height has changed. So it means that the in-between height, if you look at this height between here, is going to be 38 minus 15.1, giving you 22.9 meters. So those are the changes, and the party can now begin. So now at this point, when the two balls are moving towards each other, we have to look for the common factor. What is common between those two motions? One ball going up, the other ball going down. What is actually common? The common factor is not velocity. They have different velocities. The common factor is time. The time taken to move from this point, which is 15.1, is going to be the same time moved by ball B to the meeting point. So time is the common factor for both balls. So time is common. We have just established that. We say time taken to meet or pass is the same for ball A and ball B. So let us now look at the data we have for each ball. Let's take this one to be ball A. What do we know about ball A? We know the initial velocity. Now it has come to be 10.2 meters per second. What else do we know about? We know the common time, though we don't know the value, but we know it is there. The ball A is going upwards, so our G is going to be negative 9.8 meters per second squared. And we can say ball A, probably it covered that displacement. That's the data we have for ball A. Let's go for ball B. Okay, we know initial velocity. What is it? It is 10 meters per second. What else do we know? When we said time is common for both of them, though we don't know the value, but it's there. And G is 9.8 meters per second squared because it's going downwards. And suppose this is the displacement, then we can work out something. I want us to know that if ball A covers displacement delta x, then ball B will cover displacement, which is going to be 22, which is going to be 22.9 minus delta x. Yes, because remember this distance is 22, and if this one covers delta x, the other one will cover the entire distance here, which is 22 minus delta x. That's what we have. So we can put it here. The distance covered here is going to be 22.9 minus delta x. Thank you. So after doing that, what do? You look at the data. This data confirms which equation, or confines to which equation? It is equation 3, which says delta x is equal to vi delta t plus a half a delta t squared. Okay, so when you substitute in, our delta x is there, vi is 10.2, and time is that delta t plus a half times negative 9.8 delta t squared. Okay, when we go to this side, what do we know? It's the same data, so the same equation. Delta x is equal to vi delta t plus a half a delta t squared. But in this case, our delta x is 22.9 minus delta x, and vi is 10 delta t plus what? A half times 9.8 delta t squared. That's where we are. Okay. So what do we do when we reach this level? We need to take note. We have delta x here, and it is also here. So suppose we substitute this, because whatever we have here is delta x. Everything here is delta x. So suppose we substitute it there. It means that delta x will be out of our way. So let's try that one and we'll see where we can reach. So I'm going to say 22.9 minus this as my entire delta x, which is going to be 10.2 delta t. Okay, this is negative, so it becomes a plus, because this minus applies to the entire delta. So it's going to be minus, minus. So it's going to be plus a half times 9.8 delta t squared. Okay, this one is equal to, now I'm here, I'm done substituting. Remember, I'm substituting in this equation, is equal to 10 delta t plus a half times 9.8 delta t squared. Okay, when you reach this level, this is what you have to take note of. This one can be taken this side. So when it goes that side, it becomes a minus, and they are the same, so they cancel out. Okay, so when they are out, what do we remain with? It's going to be 22.9 minus 10.2 delta t, giving you 10 delta t. It is as simple as that now. So what do? You collect like terms, and you get 22.9 giving you 20.2 delta t. This one has gone that side to add there. Okay, and from here we have delta t, which is equal to 22.9 over 20.3. What do we get out of that? Let us see what we get. Yeah, that's what we get. 1.134 seconds. So that's the time. Remember, it's the common time which ball A traveled to meet ball B, but from this height. So after getting this time, how are we going to use it to calculate the height above which ball A passed ball B? This is what you are going to do. Ball A is going to move for 1.134 seconds, covering a particular displacement. That displacement covered, when you add it to 15.1, you'll get the height above which ball B passes ball A. So our next part is to calculate the displacement covered by ball A in 1.134 seconds. And that displacement, you add it to 15.1. Let us do that. Okay, now we are going to calculate displacement covered by the ball A in that time. What do we know about ball A? We know its initial velocity, which is, remember we are starting from here, so its initial velocity is 10.2 meters per second. What else do we know? We know it's going upwards, so G is negative 9.8 meters per second. What else do we know about A? We are looking for its displacement, and what else? We know the time. The time is 1.134 seconds. Now, when you look at this data, you ask yourself, what equation is this one? The equation is going to be the third equation, which is delta x is equal to VI delta t plus half A delta t squared. And when you substitute in 10.2 times the time plus a half times negative 9.8 times 1 0.134 squared. What you get here will be the height covered by ball A from its new position. Let us get it. So that's what we get. So in 1.134 seconds, ball A covered 5.27 meters. But the question wants the height from the ground at which the two balls pass. So we are going to add 5 to 15.1 meters to get the height. Yes, so after adding the two heights, what we get is 20.37 meters. So the two balls passed each other at the height of 20.37 meters. Yeah, it was such a marathon. Yeah, okay. We just want to close the video now. We thank you for your time, for your subscription, and we would appreciate if you click the like button. Thanks. Meet again.